Hi everyone! In this video I'm going to discuss interpreting our price elasticity of demand. This video is in basically two parts. I'm going to start by talking about the interpretation of our numerical value of our elasticity, and then I'm going to talk about interpreting whole curves as relatively inelastic or elastic. So the price elasticity of demand, which I will denote epsilon p, is a ratio of the percentage change in quantity demanded, that's on the numerator, and on the denominator we have the percentage change in price. Now the elasticity itself is a measure of responsiveness of demand to changes in price. And so these two changes are related to one another. We're looking at a percentage change in quantity demanded that has occurred as a result of a change in the price. These two percentage changes will almost always move in opposite directions, which is due to our downward sloping demand curve. Basically, either an increase in price is going to lead to a decrease in quantity demanded, or a decrease in price will lead to an increase in quantity demanded. In either case, one of the two changes, either our demand or our price, will be negative, and this is going to mean that the elasticity overall will have a negative value. In fact, because our price elasticity of demand is always assumed to be negative, sometimes some courses or textbooks only report the absolute value of the elasticity, so they ignore the negative sign. In this video, I'm going to leave the negative sign in, but you should just check for your course whether you need to include the negative or not. So there are essentially 5 sorts of values that the elasticity can take. The first case is if the percentage change in quantity is larger in magnitude or absolute value than the percentage change in price. And if we have this, then we describe this as elastic demand. As an example, let's say the price for a product decreases by 5% and the quantity demanded increases by 20% as a result. In this case, our elasticity will be -4. When we have elastic demand, the price change is relatively smaller than the change in quantity, and so the demand is being very reactive to the price change. Actually, to relate this to the word elastic, you can think about an elastic band. It's very stretchy, it's reactive to pressure, it snaps back when it's pulled. When we have elastic demand, the quantity demanded is likewise very reactive to changes to price. One useful thing to note is that we can interpret the elasticity value as the amount that our quantity demanded changes given a 1% price change. So our elasticity here would be interpreted as, for every 1% change in price, quantity demanded changes by 4% as a result. If you can't see how we get to that interpretation, note that the ratio can be interpreted as, well, for every 5% change in price, we've seen a change in demand of 20%. Well, if we divide -5 by 5, we get that denominator to -1. So we're normalizing the denominator to a 1% change. But we will have to divide the numerator by 5 as well to keep the ratio constant. 20 over 5 is 4. So here we have an equivalent ratio, which is telling us that we get a 4% quantity change for every 1% change in price. Now, when we have elastic demand, the numerator is larger in magnitude than the denominator, and this means that our elasticity will necessarily be less than -1, so like our -4 here. And that's really the formal definition of elastic demand, when the elasticity value is less than -1. In terms of real-world examples, we might think of goods with lots of different substitutes, such as particular brands of rice, sodas, so maybe Coca-Cola, or different brands of bread, as being examples of goods with probably elastic demand. For instance, if the price of one brand of rice increases, consumers can just easily switch to another brand. So the demand that that company faces would probably be fairly reactive to price changes. Now here, I will note Coca-Cola might be considered a controversial example if you think that other brands of cola like Pepsi or Dr. Pepper aren't good substitutes for Coca-Cola. Now, if our two changes are exactly equal in magnitude, this will give us what we call unit elasticity. So say for instance, if the price decreases by 6% and the quantity demanded increases by exactly 6% as a result, well, our elasticity value is going to come out as -1, and that's actually going to be true for any situation where our two changes are equal in magnitude. The elasticity will be -1 because essentially the numerator and denominator cancel each other out. So when the elasticity is equal to -1, we refer to this as unit elastic demand, and we interpret this as for a 1% change in price, demand changes by 1%. The third possibility is if the percentage change in quantity is smaller in magnitude than the percentage change in price, and this will be our inelastic demand. So for instance, if the price increases by 40% but our demand only decreases by 10% as a result, the resulting elasticity value would be -1/4. So we change the price a lot, but proportionately, demand doesn't really respond as much. Demand doesn't really react to changes in price. In these cases, our numerator is less than the denominator in magnitude. The value of the fraction will always be between 0 and -1. So that's inelastic demand. In terms of examples, life-saving drugs, water, and goods without many substitutes are more likely to have inelastic demand. So for instance, if you need some medicine to keep you alive, you are unlikely to reduce your demand for that product, even if the price of that medicine increases by a lot. Now, apart from these three cases, there are two limiting cases. If our elasticity takes on the value of 0, this is what we call perfectly inelastic demand. Basically, the price changes and there is no change to demand as a result of that price change. The second limiting case is if elasticity is -infinity, and we describe this as perfectly elastic demand. The idea is that you get some huge or infinite reaction from even a very, very small price change. So that's the 5 sorts of values that our price elasticity of demand can take. We have elastic, unit elastic, inelastic, perfectly inelastic, and perfectly elastic. In a prior video, I described how for any demand curve with any sort of slope, that we get along the demand curve all sorts of different values of elasticity depending where we are. So I'll link to that video. There is another way we discuss elasticity of demand curves, and we discuss the elasticity of the whole curve kind of relative to another curve. Specifically, we say things like the steeper the curve is, the more inelastic that demand curve is relative to the flatter curve. A good way to see why we say this is to see that for any given price change, the steeper the curve, the less the quantity demand changes in response to that price change. So for instance, here I have an identical price increase over 2 curves, and you can see that the first steeper demand curve leads to a smaller decrease in quantity demanded than the second curve. So we would describe this as, well, the first curve is more inelastic relative to the second. There are 2 limiting cases here. If we have a perfectly horizontal line, this is what we call a perfectly elastic demand curve, and actually the elasticity here is identified as -infinity. Basically, at any other price other than P star, a firm is either going to take the whole market or lose all of their demand. So you get a huge reaction even from a very, very, very small change in price. We can also get perfectly inelastic curves which are perfectly vertical. The elasticity here of the whole curve is just equal to 0. The interpretation here is that for any price, the consumer demands exactly the same quantity, Q star. One trick to remember the identification of a steep slope and perfectly vertical slope with inelastic is to see that our vertical line is like I for inelastic, whilst the horizontal line looks like the horizontal lines of E for elastic. So some people think that's cheating, but whatever helps you to understand and remember, and I think actually that really helped me when I was studying, so whatever works for you, I say just go for it. And so that's it. There is actually heaps more to talk about with elasticities. One thing I didn't get to in this video is talking about the different formulas, so how we get from those ratio of percentage changes to actual formulas that we use. So I will link to that video once I do it in the description below. It's really interesting because you can also identify the slope in those equations, which is cool. If this video helped, and I hope it really did, please like and subscribe, and just have a really great night or day, everyone.